Complementary commutation is the type of forced commutation. The complementary commutation is used to transfer the current between the two loads. Such an arrangement is as shown in this circuit. The firing of one thyristor commutates the other one. So when T1 is fired, the load R1 is connected to Vs, and at that time the capacitor C charges through R2 to a voltage Vs, and the polarities as shown here. T1 is on, then the voltage across the T1 will be 0. In this period, the voltage Vc is going to reach Vs until T1 is on. Here, this is the current waveform. When T1 is on, the current flows from Vs to the load R1 to T1 to back to Vs negative. And also the current flows plus Vs to R2 to Vc and charges the capacitor. When T2 is fired, the capacitor is then placed across the T1 and the load with R2 is connected to the supply Vs. Vs to R2 to T2 to minus Vs. Now T1 is reverse biased and it is turned off by impulse commutation. Once the thyristor T1 is switched off, the capacitor voltage is reversed to minus Vs. This is the voltage across T2. As soon as T2 is turned on, reverse voltage is going to appear across T1 and then it increases to Vs. Then capacitor voltage is going to reverse when T2 is on. So this is plus Vs and this is minus Vs. Reverse current is going to flow. This value is minus 2 Vs by R comes to 0. If the thyristor T1 is fired again, the thyristor T2 is turned off and this cycle repeats. When again T1 is turned on, the voltage across the T1 will become 0. As soon as T1 is turned on, the negative voltage is going to appear across the T2, that is Vs, Vt at Vs. Capacitor voltage is going to reverse to Vs. Now the current value is 2 Vs by R. In the initial time, when T1 is on, the voltage across the T2 will be Vs, as it is going to repeat here. Since each thyristor is switched off due to the impulse commutation, this type of commutation is sometimes known as complementary impulse commutation. This period from 0 to 0 is known as T off or circuit turn off time. As thyristor works for equal intervals, the time period will be T by 2 by T by 2. Now determine the circuit turn off time T off, and given R1, R2 is 5 ohms and C is 10 microfarads and the Vs is 100 volts. So Vs equals to, for this circuit, 1 by C integral I dt plus Vc at t equals to 0 plus R I. Assume that initially t equals to 0, the capacitor is charged to minus Vs, which equals to minus V0. When you solve our equation with this initial condition, I of t is equals to 2 Vs by R e to the power of minus t by Rc. So this is the peak value we are observing in the waveform, 2 Vs by R, with the assumption that the capacitor is initially charged. If the capacitor is not charged, then if you keep Vc t equals to 0 in the initial condition, then you are going to get Vs by R e power minus t by Rc. That is why here we are getting Vs by R. Now the capacitor voltage Vc of t is equals to Vs 1 minus 2 e to the power of minus t by Rc. The turn off time can be found with the initial condition that Vc of t equals to 0 equals to 0, t of equals to Rc ln of 2. If you substitute the value of Rc from the given data, 5 multiplied by 10 microfarads, that is 10 into 10 to the power of minus 6 ln of 2, then you will be getting T of equals to 34.7 microseconds.